Hello everyone. So today we'll be looking at this problem called counting divisors. So the problem states that you will be given n integers. So first you will take some input n and then you will be given n integers. Uh, and for each of those integers you have to print that the number of divisors they have, right? So let's just take that input and I run this loop n times. So now the point is about calculating the number of divisors. So how fast can I do that? So for that we need to see the constraints of the problem. So 10 is from 1 to 10 power 5 and x is from 1 to 10 power 6. So the very basic way that we generally do for counting the number of divisors is that we check till root x, square root of x, right? Because see what happens. Let's take a number like 15. So square root is going to be 3, like we'll round off the square root. So if we check for 1 2 3, right, so we'll get the other divisors automatically. Like if you check for 1, right, so 1 is one divisor, so 1 divides 15, the other divisor is going to be 15, so it's simply 15 divided by 1. 2 does not divide 15, 3 divides 15, right. Now the other divisor you can simply get by dividing 15 by 3, so that other divisor is 5, right? So the point is, for every divisor that's lesser than root x, there exists a divisor that's greater than root x. And if it is equal to root x, for example, if you take perfect squares, right? Like I take a perfect square like 49, where let's say 7 is a divisor that's equal to root x, right? So in such cases, you can't repeat, like you can't increment the count, right? Because then 7 into 7, so that's a special case, wherein in case of perfect squares, uh, you won't increase the count, right? So let's just start by taking input of x and let's take a counter variable, set that to 0, and I'll start a loop I equal to 1. So instead of writing I less than equal to root n, because that requires a square root function, will require extra computation, so I'll simply do it this way, that I into I less than equal to n, which is the solution of this equation is the same. It means I less than equal to root n only, right? So but I'm checking that if my x modulo I is equal to 0, then I'll simply increase my count. But another thing in that is I'll increase my count once more if my x by I is not equal to I, right? Because x by I will give me the other divisor and I is the current divisor that I have. So if they're not equal, right, that means x by I is a different divisor corresponding to I. So I'll increment my count. So if x by I is not equal to I, then I'll simply increment my count again. So I think this is where the loop ends. So I'll simply print my count. So yeah, that is the code. It's a pretty simple problem. This should work. Let's just check. So it's giving 2 2 and 0. Wait, let me just check. Okay, sorry, this is not going to be 10, this is going to be x. It's a very minor error. Yeah, now this should be working. Yes, 5 to 6, and that's the output shown here as well. So therefore it's working. Thank you. I hope you understood the problem. If you have any doubts, just post it in the comments.